She'll turn the
Okay,
other way.
so basically today we're still working on the exact same thing. Okay, we're just going to make these a little bit more difficult. So we are going to work on binomial expansion again. Okay, we're just going to make these a little bit more difficult today because you're going to deal with more coefficients as well as possibly some exponents. Okay, so for example number 1, I would like you to expand x plus 5 cubed. X plus 5 to the third power. So again, there are a series of steps that you want to go through. The first one, step 1, is always you want to figure out the number of terms. So how many terms would this expansion have? 4. Whatever the exponent is, we add 1 to the exponent. So yes, this is going to have 4 terms. So 1, 2, 3, and 4. Step 2 is that the first term will be doing what? Is it increasing or decreasing? First term is decreasing, okay? Now, I'm going to encourage you to always write your terms in parentheses from now on, mainly because we're going to deal with things that are a little bit more complicated, okay? Technically, the plus goes with the 5, okay? Just keep that in mind that the sign goes with the second term. So, the first term is going to be decreasing. So, your first term is x, and what is its exponent when it starts? X to the what power? Matches the exponent on the problem, so x to the third, and then we're descending, so x to the second, x to the first, and x to the 0. Then we take our second term, and it will be doing what? Increasing. Okay, so you're going to take the entire 5. Technically, it's a plus 5. You don't have to write the plus in there because that's not going to change anything. So 5 to the 0, then 5 to the first, 5 squared, and 5 cubed. What's our next step? The Pascal's triangle coefficient. Okay, so triangle coefficient, you can write Pascal's in there if you feel like you need to, but I don't think you need to. You have that chart, okay? So you have that the pattern chart. What would the coefficients be if you have a 3 as an exponent?
1, 3.
1, 3, 3, and 1. Okay, and eventually, 3 is a pretty common exponent, so you'll probably memorize that if you haven't already. And then we just want to clean things up. Okay, so last step is cleanup. Okay, so underneath here, I'm just writing what I'm going to multiply together. I'm not actually writing the term. I'm just writing what I'm going to multiply together. So this is really 1 times x cubed, 5 to the 0. Anything to the 0 gives you what? 1. So really, your first term is just x cubed. Okay, next term is going to be 3 times x squared times 5 to the first is 5. So if you multiply all that together, what's your second term? 15 x squared. Don't forget that if it's a positive, you have to put the plus sign. Okay, a lot of times people forget the plus signs there, and then it just looks like a giant multiplication problem, and you're going to lose a lot of points for something that's kind of silly. Next term is 3 times x times what's 5 squared? 25. Okay, so multiply the 3 and the 25. That gives you positive 75x. And then your last term is really going to be 1 times x to the 0 is 1 times what's 5 cubed?
125.
125. If you multiply those all together, you get plus 125. And that's your answer that we're looking for. Questions on how I did that? So hopefully not too bad. Okay, just like yesterday, we're just going to be adding a couple more coefficients and numbers inside the terms. Okay, let's try another one. Number 2. Again, I'd like you to expand the binomial x cubed minus 2y to the 4th power. X cubed minus 2y to the 4th power. So, same steps we're going to follow. Number 1 is figure out the number of terms. So how many total terms would there be in this expansion? 5, okay? Exponent of 4 means you add 1. So we're going to have 5 terms, so 5 spaces. 2. Then your next one is you're going to do the first term, and it is doing what? Increasing or decreasing? Decreasing. That's honestly one of the hardest parts for people is just to remember which one increases, which one decreases. Once you can keep that straight, it should be fairly basic. You're just plugging in and doing the exact same steps. So the actual first term here is x cubed. Your second term is the whole -2 and the y. Okay, so make sure you kind of split those up. So the first term is going to be decreasing, so we're going to start with x cubed. What does it start with for its power? To the what power? The fourth. Make sure that you write that on the outside because you are going to have to distribute those powers, so you will multiply. So x cubed cubed, x cubed squared, and what's inside the parentheses is never going to change. That's still going to say x to the third. Then to the first, and x to the third to the 0 power. Our second term will be doing what? Increasing or decreasing exponent value. Increasing an exponent value. Remember, your whole second term is negative and the 2 and the y. So the whole -2y, what do you start with for your power? 0. -2y to the first, -2y squared, -2y cubed, and -2y to the fourth power. Next, we want to put in our triangle coefficients from Pascal's triangle. What will the coefficients be for this expansion? 1, 4, 6, 4, 1. Again, that's another one that's pretty common that you'll probably memorize at some point. 1, 4, 6, 4, 1. And then your last step, and unfortunately probably the most important, is the cleanup step. And sometimes the most difficult because you actually have to do some multiplication there. So really this is going to be 1 times, what's x cubed to the fourth power? X to the, do you add or multiply those? Multiply, so x to the 12th. Then you have -2 to the 0, so that's multiplied by a 1, and a y to the 0, so multiplied by a 1 again. All those ones, they multiply together, you kind of drop them, and we get x to the 12th power. Then here, you're going to multiply 4 times x cubed cubed is what? X to the 9th times -2 to the first is multiplied by -2 and multiplied by 1y. Make sure that when you multiply these together, you're not doing 4 minus 2, okay? This is multiplication still. So your next term is -8x to the 9th y. Third term is 6 times x to the what power? 6. X to the 6th. -2 to the second power gives you what? Positive 4, and then a y to the second. If you multiply these together, 6 and 4 gives you a positive 24. You do have to put that sign there, so put plus 24. X to the 6th, y squared. Then we're going to clean up. 4 times x cubed to the first power is just x to the third. What's -2 cubed? -8. And you're going to have y cubed. Multiply those together, and we got -32 x cubed, y cubed. And then your last step, this is going to be 1 times, what's x cubed to the 0 power? 1. Just 1. Okay, and then -2 to the fourth gives you what? Positive 16, and a y to the fourth. Multiply those together, and you get a positive 16 y to the fourth. Okay, whenever you have a negative in your original expansion, just notice, and hopefully this is kind of a way you can check your work, that your terms will alternate between positive, negative, positive, negative, positive, negative. Okay, it always starts positive and then goes negative. It's just the way that all the expansions are going to end up working out. Questions, confusion on how I did that? Not too bad, hopefully. Okay, this one will probably be the most difficult for the day. In fact, I'm telling you for sure it will be. Okay, I would like you to expand. That doesn't mean it's something that you can't do, though. Okay, expand x over 2 plus, oh my god, it's just a fraction, guys. X over 2 plus y over 3 cubed. X over 2 plus y over 3 to the third power. You are still following the exact same steps. Okay, it just has a fraction on the bottom. It's okay. It's gonna be okay. They're just numbers. It's gonna be okay. I'm gonna help you. We're gonna make it okay. Or die trying. Sure. Okay. Number 1. What's the first step you need to figure out?
Number of terms.
Number of terms. So how many terms would be in this expansion? 4 terms, because there's 3, or your total exponent is a 3. So 4 terms, so I'm going to do 1, 2, 3, and 4. First term is doing what? Increasing or decreasing in exponent value?
Decreasing.
Decreasing. Okay, so your first term is actually the x over 2. Your second term is the y over 3. You don't have to worry about taking the positive or negative or anything like that with it. So your first term is going to be decreasing. So the whole x over 2. What exponent do I start with?
3.
Third. Then x over 2 to the second. X over 2 to the first. And x over 2 to the 0 power. Fill in your second term, and it is increasing. So the whole y over 3, and it starts at the 0. We always start to the 0 power, so y over 3 to the 0, y over 3 to the first, y over 3 squared, and y over 3 cubed. Now, just because there's numbers in the denominator here, you still have to put in the coefficients, okay? A lot of people skip that step because they think, oh, there's already numbers there. It doesn't work that way, okay? You do still have to put in your triangle coefficients. If we have a total power of 3, what will my triangle coefficients be? 1, 3, 3, 1. Can't remember that. That's why we gave you the pattern chart. And then the last step, probably the most difficult, is the cleanup step. Okay, this is not something that you can't do. You will be okay. Okay, so really this is going to be 1 times x to the third gives you x cubed. Over, don't forget you have to distribute the exponents to both the top and the bottom. What's 2 to the third power? 8. Okay, if you could just write 2 to the third and then simplify it in another step, but you really don't need to do them separately. And then y to the 0, or actually y over 3 to the 0 power gives you what? 1. So your entire first term is just x cubed over 8. Then this one we're going to simplify again. So 3 times x squared over what? 2 squared would give you 4 in the denominator, multiplied by y over 3 to the first is just y over 3. Now, you can multiply this all together and then reduce, but kind of, I think the smarter thing to do would be to reduce earlier. So here, the 3 and 3 can cancel each other out. Basically, they reduce each other away. So what's your actual next term? X squared y over 4. Okay? Don't forget, you have to put the positive in there. Okay, so these just multiply together. It's nothing different. Okay, so you want to try to cross-reduce if you can. And if you can't, you just multiply the tops together, multiply the bottoms. You don't see that you can cross-reduce, you can always take an extra step to reduce later. Then here, this is 3 times x over 2 to the first is just x over 2. Y over 3 squared would give you what? Y squared over 9. Okay, don't forget this exponent does belong to the denominator as well. Then we can cross-reduce. Okay, the 3 and the 9 can reduce, and it leaves you a 1 and a 3 in the denominator. So if you multiply across the top, multiply across the bottom, your next term should be positive xy squared over what? 6. Okay, and then finally here, this is going to be 1 times what's x over 2 to the 0 power? 1. How about y over 3 cubed? Y cubed over 27. Okay, it's not going to be crazy numbers that you can't figure out the squares or cubes of. Okay, and then your next term will be plus y cubed over 27. You do not have to add these together. You don't have to get a common denominator or anything like that. You're just multiplying. Okay, so I promise you, it's really not going to be that bad. Any questions on how we did that? Okay, now we're going to do a very, very, very small amount of review, okay, from our last unit, because we are going to use some of this stuff. Okay, so review, and you're not going to use it today, but you will need to know how to do this, okay? You're not going to see why you need to know this, but just know that you do. If I ask you to do 4C2, how do we do that? 4C2, not necessarily on your calculator. So basically, what's the formula for, this is a combination. So NCR formula is equal to n factorial over what?
R factorial.
R factorial times n minus r factorial. I graded your group quizzes, and it was really sad that a bunch of you guys like didn't know that. Okay, you put the wrong one. That's like inexcusable. Okay, it's a formula. You just have to memorize it. So here, if you figure this out, this is going to be 4 factorial over what? 2 factorial and another 2 factorial. Okay. If you worked this out, this would be 4 times 3 times 2 times 1 over 2 and 1 and another 2 and 1. You can reduce any way you see fit. Does not matter to me. Okay, I would reduce the 2 and the 1 with the whole 4 because I think it's just a little bit easier. You don't have to. Okay, 4C2 does end up giving you an answer of 6. Okay, we will be working with these a little bit on block day. Okay, so just make sure that you remember combinations. And then the last one I want to go over, this is going to be, I'm going to ask you this a little bit differently. Okay, 9C2. Okay, how would you write 9C2? And I don't want the actual answer. I just want to know, how would you write it using the formula? 9 factorial over what? 2 factorial, 7 factorial. Would you say that this is equivalent? Is this equivalent to 9 factorial over 7 factorial, 2 factorial? Yes. Are these equivalent? Yes. But what is this the combination form of? Oh. Combination with what numbers there? 9 and 7. So my point here is I want you to understand that 9C2 is equivalent to 9C7. Okay? At some point, we are going to need to know these. And on your actually on the board today, it says you have a book assignment. I'm actually going to change that, and I'm going to give you a worksheet instead because the book assignment is just not very good, in my opinion. So I'm going to give you a worksheet instead. We're going to ask you to calculate these. Okay? You can use your calculator, but understand that these are equivalent. Okay, we are going to need to know that at some point. Okay, so homework is going to be worksheet 2, which I will give you as a handout. You're doing numbers 1 through 15. Okay, almost half of them, though, is just plugging in combinations on your calculator. And yes, you can use a calculator on this unit. Anyone have questions?